Yes, it's television, seen from the other side of the screen. Television that entertains and enlightens, that soothes, stimulates and inspires. The TV set today is an essential item of domestic equipment, a must in every home. But how, among the variety of models offered in the shops, is the man in the street to know which one to choose? What are the things that matter most? The styling of the cabinet, the quality of the picture, the sound, the price? Yes, all these things are important. But most important of all is the chassis itself. A complicated piece of electronic equipment with more than 1,000 parts, all assembled with precision circuitry to produce an instrument that will give years of dependable service for your enjoyment. Let's visit the works of the largest television manufacturing company in Britain and meet some of the people behind the scenes whose skill and ingenuity make it possible for us to enjoy television at such modest cost. For remember, British television sets are the cheapest in the world, and that no country gives the public such remarkably good value for money. Here in the Ferguson laboratories, highly trained specialist engineers work unceasingly in designing and developing new circuits, new components, newer and better techniques, all directed to the ultimate aim of giving the public better quality and better value for money than ever before. In adjoining studios, a team of imaginative young designers work on the presentation of new models. There is undoubtedly a fashion aspect in the design of radio and television receivers, and here have originated many styling trends that have spread throughout the industry. The growing use of printed circuits, or more correctly, printed wiring, in the assembly of domestic radio and television receivers is a development that follows logically upon the use of similar systems for many years in the production of equipment for the services, communications receivers, scientific instruments, automatic telephone switchboards, electronic computers, and so on. One of the main advantages of printed circuitry is that it enables efficient large-scale production to be achieved by the use of high-speed automatic assembly equipment. The Ferguson Television factory at Enfield is the first in Europe to be equipped with such an assembly line, making full use of automatic machinery. The printed board starts as a copper-clad resin-bonded laminate sheet. The layer of electrolytic copper, 1.5 thousandths of an inch thick, is manufactured by the Royal Mint, the only people in the United Kingdom able to supply copper of this type and quality. The blanks, cut to the required dimensions, are conveyed mechanically to the printing section. The circuit pattern is machine printed onto the copper surface of the board by the silk screen process with an oil-based acid-resistant ink. In this section of the factory, more than 2 million square inches of coppered board are processed every week. The printed boards are carried on a circulating conveyor which takes them through an infrared drying oven. The dried boards are then offloaded onto another conveyor, taking them into the etching plant. This installation carries out the etching process automatically in glass-sided tunnels. The boards are cleaned and sprayed with acid, which dissolves away the exposed copper, leaving a pattern of metal only where it is protected by the ink. A water wash then removes all traces of the acid, and a stripping solution dissolves and removes the ink. The boards are now brightened, that is to say, oxidization is removed in a solution which gives a mirror-bright finish to ensure that the surface of the copper is chemically clean. A coating of preservative lacquer is then applied. Before passing to the automatic assembly unit, a solder-resistant pattern is printed onto the copper face of the board to mask it, except at the points where solder is ultimately required. The use of solder resist not only makes for neater appearance, but by covering only very small areas, surface tension of the molten solder provides a bigger build-up on the points required, resulting in better joints both electrically and mechanically. A thorough visual examination completes the preparation of the board before being passed to the automatic assembly line. This automatic assembly unit, 80 feet long, is one of the most remarkable examples of electronically controlled production equipment yet devised. Into it is fed a continuous stream of printed boards, upon which it mounts the components without human aid. Despite the fine tolerances required, the machine can easily be adjusted for different circuitry of any reasonable size. Notwithstanding the complex nature of the final product, the process is fully automatic, the only human intervention being adjustment and maintenance of the machine. Nearly all the mechanism on this assembly unit has been built and installed by Ferguson engineers. 2 printed boards are used on Ferguson television receivers, the intermediate frequency board and the power board. A typical IF board passes along the guide rails in approximately 6 minutes, and during this time is fitted with no fewer than 85 components, including resistors, terminal pins, valve holders and jumper wires. In a similar manner, the power board is fitted with 75 components. Resistors are bandolier mounted on sticky tape for feeding to the inserter heads. Automatic insertion demands that components must be made to more precise physical specifications than have previously been necessary. They must also be pre-formed, that is, the resistors, for example, supplied to the machine with lead wires cut to exactly the right length, within 1/1000th of an inch. The components are fed to the inserter heads from drum magazines and bandoliers, each holding 2,500 components. These are valve holder units, complete with their loaded drum magazines, from which the valve holders are chute-fed to the inserter heads. Note that each valve holder has 9 separate lugs, each of which must locate accurately in its appropriate hole in the board. Such is the measure of precision demanded of each component, of the indexing of the board on its guide rails, and of the insertion mechanisms. The assembly equipment uses 75 inserter heads, all individually adjustable. Each head is electronically controlled and is operated by compressed air at a pressure of 100 pounds per square inch. The time cycle mechanism, also electronically controlled, is regulated by the speed of the heads. With all the bandoliers and drums full, the machine is able to mount 2,500 boards without human aid. An electronically controlled braking mechanism is fitted, which automatically stops the machine when an inserter head exhausts its supply of components. This automatic equipment enables complete sub-assemblies, wired, aligned and tested, to be fed to the main assembly lines. A significant advance which not only ensures greater consistency and eliminates errors due to the human element, but also gives higher productivity through the more efficient use of the available labor force. Larger components, such as IF transformers, are fitted on an adjacent assembly unit, and the boards are then ready for soldering. The flow soldering method employed here is quite new and has proved both reliable and economic. The circuit boards are conducted at a predetermined speed along a conveyor, where they pass over a pumped-up wave of molten solder, which effectively solders the circuit connections. Each board takes 8 seconds to pass over the solder wave, and in this time, more than 500 perfect joints are made. So efficient is this method that the incidence of faulty joints has been reduced to 1 in 100,000. From the solder wave, the boards pass straight to a series of automatic electrical tests. The IF board passes through 2 electronic test consoles of the type seen here, the first of which checks for open circuits and that all resistors are in position and are correct. In these routiners, the assembled board is compared with a known standard master board, and any differences are immediately apparent. The second console bridges the capacitors and those resistors with critical tolerances to ensure that they are present and correct within the prescribed limits. This automatic test equipment carries out approximately 300 individual checks before the board is passed to alignment. Service engineers will appreciate how long these checks would take by normal methods. On this precision test equipment, designed and built by Ferguson engineers, all 300 checks are carried out automatically in 10 seconds. After passing through this bridging sequence, the board is visually examined before being placed on an overhead conveyor at a level indicating that it is ready for alignment. Alignment of the IF board is carried out by employing crystal-controlled spot frequencies fed in time sequence to the input circuit of the board, the outputs being displayed visually on a cathode ray tube screen. The individual tuned circuits to which each frequency applies are then aligned against the amplitude of the appropriate step on the trace. The IF board is not a complete receiver in itself, but this console provides the remainder of the circuits, enabling the board to be picture tested before being conveyed to the main assembly lines. The completely assembled printed boards now have to be mounted together with the necessary metalwork, other components and sub-assemblies. Here in the main factory, the most up-to-date flowline methods are used to reduce handling to a minimum. An overhead conveyor system is employed, and this circulates continuously throughout the assembly hall. Onto it, in the material stores, are loaded all the main items that the operators require: the metal parts, the line output transformer, the deflection coils, the tuner plate, and the IF and power pack printed board assemblies. As the conveyor passes along the assembly line, each skilled operator takes from the moving trays the component she requires for her particular part of the job. Firstly, the metal framework is put together to form the chassis into which the various components will be mounted. The power board and tuner plate assembly are linked together and connected up. At the next stage, these units are placed into the chassis and wired up with the other components. Automatic tools are used to secure the connecting wires to their terminal posts. These make tight wrap-round joints of great mechanical strength, making perfect electrical contact. The line output transformer, a vital specially designed component made and pre-tested in another part of the factory, is now fitted into position and connected up. The partly assembled chassis now passes one of the many inspection points where it is checked that everything is correctly connected. Now the intermediate frequency printed board assembly is mounted into position at the top of the chassis frame and is secured on hinges to facilitate access for servicing purposes. Connecting leads from the tuner plate are brought through for attachment to the IF board. Speedily and accurately, the operators on these assembly lines carry out their tasks with dexterity born of long experience. Here, the final links between the tuner plate and the IF board are being made. Assembly of the chassis is now virtually completed, and all that remains is to fit the cathode ray tube, which is brought in on the overhead conveyor. A rubber mounting cushion is placed round the edge of the tube, and then the deflection coil assembly and its nylon housing is fitted round the tube neck and secured by a nylon screw. The tube is placed into position in the chassis and secured firmly. Before passing to its functional tests, the chassis is now given a final inspection to ensure that everything is correctly fitted and properly connected. passed now onto the conveyor to be carried into the main test bay. The completed chassis now undergoes a functional test. From a signal generated within the factory, a test card pattern is fed into the receiver and various adjustments are made to bring the picture within the limits of the operating controls. Next, the intermediate frequencies are aligned and checked from the visual pattern on an oscilloscope. Now the cabinet is prepared to receive its chassis. The speaker unit is fitted. A further alignment check is made, and the chassis is fitted into its cabinet. After a final check and a rocking test, the factory route card is exchanged for the guarantee card and a serial number is allocated. We have seen in these pictures one of the many different types of television receivers which are made here every day. In the production manager's office, each fully completed receiver is registered automatically on a visual indicator, showing at a glance how many of each model has been manufactured that day. One last appearance inspection and the receiver is packed into its carton and passes out on its way to the dealer's showrooms en route to the consumer. By unceasing research in the laboratories, the latest production techniques, and constant vigilance and attention to detail, the Ferguson men of vision ensure that the receivers of today are in the forefront and worthily uphold the traditions they inherit.